Hi friends, welcome back to the channel. Today we are going to be looking at render batching, which I'm sort of excited about, and also a little concerned about, mostly because this is venturing into the very extensive list of things I haven't done yet in graphics programming, compared to the alternative, which is a very short list. Anyway, we're just going to hop right in. We've got a couple of things that we need to update about how the renderer is currently working before we start. So we're going to start with those, and I'll explain them as we go. So essentially, we have, we need to update the vertex buffer. And the reason for that is currently we've got the ability to create a new vertex buffer from a vector or from a static array, but what we need is a dynamic buffer. The reason we need a dynamic buffer is currently we're saying we're creating a single vertex buffer for our positions that is just like 1 0 0 1 whatever, you know, and then a static vertex buffer for our texture coordinates, and those are always exactly the same, and we're passing that like vanilla quad layout to the shader along with a transformation matrix and telling the shader to figure out where it goes. We can't do that with the with batching. Or we might be able to do that, honestly, maybe, I don't know. But what we're going to do instead is we're going to actually compute where the modified positions of each quad should be. And so for that, excuse me, for that, we need to essentially create the... Yeah, I don't know, man. We need to essentially take that data and upload it into an array, or into a buffer. But then for the next frame, we might have different quads, and so we need to take that data and we need to upload it into the buffer. And so for the next frame, we'll have different stuff we upload it to the buffer. And we can do that theoretically with a static draw buffer. But the problem becomes that that's kind of slow. The graphics card is not expecting us to be updating that every frame, and so it's not really stored in a place that is easily accessible and modifiable. And so what we need is a way to create a dynamic buffer, and that's what we're going to create. So we're going to do pub unsafe function dynamic new. I feel like I didn't do a great job of explaining that. And I'm actually going to give this a type specifier, and I'll explain why in just a second, but essentially we're just going to take account for how many pieces, how many items should be in the buffer, right? And actually, let's make that return self. Boom. So first thing we're going to do is let mutable ID as a U32, and then GL gen buffers. So this starts out the same, and actually a lot of this is going to be the same, you guys will see. Whoops. Mutable ID, so now we have our buffer ID. So we're going to bind the buffer as a, whoops. Hello? That was weird. Okay. As a GL array buffer. And we're going to give it the ID. So there's our creating and binding. And then we're still calling GL buffer data, but we're going to do a fun little thing here, which is not give it any data. Right? Which sounds kind of weird, but essentially what we're going to do here is first we're going to do count, and this is why I've given it the type specifier, the generic, because I want to be able to just call size of there. So essentially I give like whatever data is going to be stored there, whether it's a vector 2, vector 3, etc. I don't have to write different functions for all of these. I don't have to compute the size in bytes when I call the function, I just need to tell it what's being stored in this buffer and how many things of that type are being stored. So here, this is where we would add the data. Instead, we're going to add, we're going to give it 0, which is essentially equivalent to null pointer. We're giving it 0 data. And then the last thing is we're going to do GL dynamic draw. And that's the end of that. And then we've created it. Now we're just going to unbind it. So same way. We just bind 0 to the active array buffer. And then we're going to return our vertex buffer. And so this vertex buffer actually, let's see. So I actually have a T here. So this may or may not cause an issue by including it there. I don't think it will, because then I'm still just going to do the same ID and then set the data to phantom data. Oops. Okay, yeah, so it's angry that I've done that. T is already used for generic parameter. Oh, great. Okay, so since I have the T on the implementation, the struct itself is getting the generic, which that works out. Great. Okay. So this is all that I needed to do for the vertex buffer. But yeah, so now we're just gonna hop in to setting up the renderer. So we've got a couple of things that we need to change. First of all, we're not gonna have a singular quad vertex array. We are still gonna have the default shader and texture. But essentially, I need a few constants, and I'm gonna leave these guys here, but I'm gonna comment them out. Oops, that is not what I wanted to do. Hello. What keybind did I just hit? Great. Okay, so we're going to comment those out. And that's going to cause some errors down the line, but that's fine. And yeah, so now I need a couple of constants. First, we're going to say, let's just say max quads. Right, this is going to be easy, which is going to be a U32. And we're gonna start with just 1,000 quads and no mas. Actually 10,000 quads. And then so from there we can determine that our max vertices, is going to be, what the hell, Anthony? Max quads times, let's see, for each. Yeah, okay, so for each quad, we're going to have 4 vertices, right? And this is where things are going to differ dramatically from what we've been doing, in that we're going to switch from using GL triangle strip to draw the quads to GL triangles, which is going to mean that it has to be indexed. And so we're also going to have a const max. Oops, that was weird. Indices U32 equals max quads times 6 here. And so that's creating each of the, what is this? Similarly named constant max vertices defined here. Do I have a max vertices somewhere? What? Oh, I think it's just trying to give me a hint that something, okay, that's fine, we're gonna leave that. All right, so that's going to determine how many things we can draw. Those are in constants. We can, if we want to change how many things we're doing in a single batch, we can just edit the max quads number, and that will update everything for us. And here's the other thing that we need to be doing. First of all, this is just going to be VAO, which is going to be a vertex array. This is going to be our entire batch vertex array. We're also going to make a pub positions, which is going to be a vertex buffer on a vec3, right? Rotations is going to be a vertex buffer on a float f32, not a double. Pub text chords is going to be a vertex buffer on a vec2. What else do we need? We're also going to need to have IDs for textures. We'll get into that here in a bit. Does not implement debug. Okay, we'll go back and fix that real quick. Let's derive debug. Great. Okay, what is text chords here? Should have a snake case name. I guess you are correct, technically. Great. Cool. So, for each of these VBOs, we're going to say, this vertex array is no longer going to be triangle strip, it's going to be GL triangles. And then we're not going to be setting the vertex count. We're going to do, we're no longer doing that. Yeah, we're going to have a lot of changes here. Okay, then there's our, oh, and then I also need one for indices. Okay, pub, VAO, and then the EBO is going to be an index buffer. Right, and then I guess that also does not implement debug. So let's fix that. Whoops. Come on now. There we go. Great. Whoop. Cannot find, and oh, apparently I didn't even have it pulled in. And then here, index buffer. Great. Okay, so now we're back here. Let's remove highlighting. Okay, so this, we just need to give it VAO, but it's also angry because we're missing some things. Okay, so we bind the VAO. Then we're gonna say let mutable v, let's see, what did I say? Positions equal vertex buffer. And it's going to be a vec3 for the position. Dot dynamic new. And our size for the positions, that's going to be each individual vertex is going to be max vertices, right? Why is it angry here? Dynamic new vec3, like that? Nope, not happy about that either. Vertex buffer, okay. So it just doesn't know vec3, like that? No? Okay, come on, why is it? Oh, expected U size found U32. That's a good point. Let's go back up here. U size, U size, U size. Okay, no highlighting. Great. Okay, so that was in fact how I needed to do that. Now we're going to have positions. What else did I have? Rotations. And this is gonna, whoops, gonna be an F32. Then I need text chords. What else are we gonna need? We're gonna need text chords. We're gonna need a pub text ID, which is gonna be a vertex buffer on a u32, right? And then a pub colors is going to be a vertex buffer on a vec4, which I don't know that I have in here yet. Oh, apparently I do. Great. Okay. Okay, text coords, let mutable text IDs equal vertex buffer. Why am I doing it like this? Okay. Text IDs and then colors. Text ID here needs to be a u32 and then a vec4. And then, yeah, that's all going to be for the max vertices. Okay, and so here's a point I want to make really quick, is I know this looks wasteful. However, it's not as wasteful as it looks. It is still slightly wasteful by some small margin, because for each of these vertex buffers, I have to also allocate the ID and keep track of different allocations. However, if I were to, so this is leaning into the structural arrays that I talked about in the last video. If I were to do an array of structs, which would be a single vertex buffer that is holding all of these things in their own struct, I could also do that. Honestly, in a 2D renderer, there's probably not going to be that big of a difference between doing one or the other. I just find multiple vertex buffers easier to use. And if you think about it, the actual size of the arrays in the GPU that are being allocated is the same. It's still, 10,000, 40,000 vector 3s, 40,000 floats, 40,000 vector 2s, all of those things. It's just they're all separated into their own arrays. So anyway, let's see, what else was that all of the stuff that I needed? Okay, so we're gonna do positions.bind, and then we're gonna say VAO dot, what is the link attributes? Okay, so positions, and then we need the layout here is going to be 0. Number of components is what, oh god, I don't remember what this was supposed to, good lord. Alright, let's save this really quick, get diff, past that, just cheat off of my past self real quick. Number of components here, okay, that's the individual thing. Okay, yeah, I got it. So since positions is a vector 3, that's a 3. And then the attribute type here is GL float, and then what was it? Standard mem size of vec3 as I32, 0 as const. Boom. And now we're going to grab both of those. 2, 3, 4, 5. Great. So then we bind our rotations. And then here it is rotations. We have layout 1, and it's only a single float. And then size of F32, which I know is 4, but that's fine. I'm going to leave it like that just for shiggles. Cool. Text coords. And then here, text coords. And that's going to be, whoops, layout 2. Whoop. And then the texture coordinates are a vector 2, so we only need 2 there. And there we go. And then what's next? Text IDs. right? So text IDs, why is that angry? Anything fields, colors, EVO position, oh, because I haven't saved yet and it still thinks that I'm, yeah, that's fine. All right, so this is going to be layout 3, and our text IDs only have one thing, and it is an unsigned int. There we go. And then here it is U32, which again, I know is 4 bytes. That's fine. Oops, too far. And then finally colors. And then we're going to add in the colors there. This is layout 4. There are 4 items, all of floats, because this is a vec4. Cool. And then here we have VAO. I do also need to set up the EBO, which we will do in a second. In the meantime, we're going to say positions, rotations, text coords, text IDs, and colors. And now it's still mad about the EBO, which I believe needs to, oops, here we go, needs to be here. But now it's angry that the EBO doesn't actually exist. Let mutable EBO equal index buffer new. Yeah, okay, see, I feel like I need to give it, do I give this one a I think this one also needs to have a dynamic option. All right, let's go do that really quick. Poop-a-doo. And we're essentially going to be doing the same thing. Pub, unsafe function, dynamic new, and then it's just going to be count as a usize. Oops, hello, self. There we go, and we're just going to copy this because that's a little faster. Yoink. And there we go. Element array buffer, ID. Okay, instead of indices dot length times 4. What? Out. Indices dot length times 4. What is the 4? 4 bytes because I'm using a U32? Yeah, that's it. 4 bytes because I'm using a U32. That's fine. Count times 4. And then here we're going to also give it no data. So 0 as const. There we go. And this is dynamic draw. Whoops. Boom. Yeah, that ought to do it. And then we're going to say let mutable EBO equal index buffer dynamic new max indices. Okay. And then that seems to have resolved those errors. Great. So that is all of our stuff set up. My watch battery is low and it's very angry about that. Okay. So that's got all of our context set up. Before we draw, let's set up our function. So we're going to say unsafe function. We're going to create a flush function. And what flush is going to do is it's going to upload all of our buffer data to the buffers that they belong to. And then we're also going to make an execute function, right? And that's going to just call the render command that's going to do the drawing. And so here, that actually should be as easy as, what did I do up here? Right, yeah, that's got a draw. And then let me double check on that actually. If I look at render commands, Yeah, so I have just the draw. If I have an index count, then it's going to do draw index. Otherwise, it's going to do draw arrays. So we want to make sure that we set our index count, which we're going to do in our thing up. We're gonna say, I may end up having to update some of that, but for now, we're just going to say draw, and we're going to give it, oh, actually, I need to do if let some context equal render context. Then here we're going to say draw context.vao, right? So all that's going to do, we got to get out of that, that's bugging me. All that's going to do is send our VAO, which by the time we're going to call flush, then we're going to call execute. So by the time we call flush, everything should be in the VAO properly, then we call execute, and boom, we draw. Okay, so we're going to say for flush, let's see, what do we need to do? Let's set up up here. We're gonna do. So we got our mutable. Do I want the count on the vertices and like our current vertex and index counts to be here, or do I want them to be in the render context? I think I'll just have them here, right? So here we're gonna do a static mutable. I guess it does have to be an array and not a vector, right? But that's okay. I can static mutable. We're going to call it batch vertices, and that's going to be a vec3 with a size of max vertices. Equals, yeah, and we'll just, no. Okay, so I do want this to be in the context, and here's why. So I love being able to just specifically do arrays which are allocated on the stack. I know that they're gonna like clean themselves up as soon as the stack frame goes back down to the calling function. That's great. Can't do that here. I probably could do that here, but at that point, like, we're talking about allocating like thousands upon thousands upon thousands of bytes of data on the stack. And up to a certain point, we could probably get away with that, but I would much rather set this up as a vector inside of the render context. So we're going to say pub vertices is going to be a vector of vec3s, right? And pub indices is going to be a vector of sorry, my brain just died. U32. There we go. And then here, actually, I've got the render context itself marked as mutable, so that should be fine. Oh, here's a thing that I didn't do, ebo.bind, right? And then, do I need to bind the EBO before I do anything with the attributes on the VAO? I don't know. I didn't have it set up for that before. I don't know. We're going to see how this goes. And then... Yeah, you know what? I'll just go ahead and move this up here. And then down here, we're just going to do vao.unbind. And then, let's see, colors was the last one, but it doesn't really matter. Colors.unbind. And then ebo.unbind. And then this is angry because I need to do what is it? Vertices as a vec of a vec3. How can I just do vec new? Does not allocate until anything is pushed into it. All right. Let's see. I need to double check if I can just allocate that with a size. Right. Rust vec with size. Vector with size defined at runtime from number of items value to replicate. Oh, great. Wait, so is that from... Nope. So it's standard vec from... is that no longer valid? Oh, I can do it like that? Oh, great, 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 awesome. Vec, then we're gonna do vec3, 0, and our size is going to be max vertices, if I could spell. Oh. And then indices, this is gonna be a U32. This just needs to be 0 and max indices, right? And then at this point, vertices, indices. That's getting a little lengthy. Okay, now I've got an error down here. Okay, that's back to, great. Okay, so I've got my vertices and indices. So, oh, wait. That means I need to keep a... Ooh, okay. Yeah, so that means that I need to keep the... I need to have vectors for each individual. Yeah, okay. All right. Oh yeah, no, okay. I'm losing my mind. All right, we're good. So we're gonna change this slightly. This is going to be positions, if I could type. Position data. There we go, that's good. Rotations, text coords, text IDs, colors. All right, rotation data, text coord data, whoops, text ID data, and color data. Okay, and so then here we do an F32, whoops. Text coord, we do a vector2, text ID, we do a U32. Whoops, okay, come on in. And color data, we do a vec4. Great. Now back down here. Okay, so my brain was struggling because I thought I was allocating all of these things twice, but I'm not. I'm allocating them once in RAM and once in VRAM. So the setting up the vertex buffers here with the dynamic new and giving them a size, that is allocating the ID in RAM, but it's allocating that buffer data or the space for those buffers on the graphics card. I still need to have somewhere in RAM to store my vertex data. Okay, so this is position data, right? And then we do, excuse me, rotation data. And then we do text coord data. Oops, hello. How do I go forward? There we go. And then text ID data, right? And then, oh yeah, I had an extra one. And then color data. Okay, so this is a vec4, this is a U32, this is a vec2, and this is an F32, right? So now we just go in and we edit these. So that's 0, text coord data becomes vector2.0, texture ID data becomes 0, and color data is vector4, 0. Great. Okay, and then down here, this is getting very lengthy. I need to reformat this to be on more than one line. Right, okay, so position data, text coord, or let's do them in order. Rotation data, text coord data, text ID data, and color data. Boom. Yeah, that is a very long line. That really needs to be edited, and I'm going to do that right now. Okay, so then, since I've saved all of my VBOs, and I've saved all of my data, now for flush, well, there's one other thing that I need to do, because those are all allocated completely. We need to do pub vertex count. Actually, no. Vertex. Yeah, vertex count is gonna be a U size, and index count is going to be a U size. Nope, those need to be commas. And then, good lord, vertex count is 0, index count is 0. Great, okay. I'm getting really tired of jumping back and forth here. That's fine. Okay, so now we can, during the draw quad calls, we'll be able to upload or set data in those vectors and also increment our vertex and index count so that we never have to worry about like deallocating, reallocating. It's just the size of the vector. Whew. Okay. Now we're gonna do, say function flush. For flush, we're gonna do, we need to create a set data function, right? Okay, so for our, we need to implement this for vertex buffer and index buffer, which is fine. Let's go here, and then pub, and say function set data. We're gonna give it self. We are going to give it the data, which is going to be a vec of t, and we're going to give it the count. Yeah, the count, which is going to be a U size. Right? And then what we're going to do here is GL, or we'll just call self.bind, and then GL buffer subdata, right? So our target here is self.id. Our offset is 0. I don't know that, at least not for the 2D, for the 2D renderer, we're certainly not going to be updating like individual slices of this stuff, so that's fine. Our data here is going to be, what is it? Data dot as pointer dot cast, and then our, oh, it was size first. I'm sorry. So then for our size, it's going to be count times standard mem size of, whoops, t as I32 I size. And then our data is going to be data dot as pointer, oops, hello, dot cast. Right? No errors? Great. Self.unbind. Because then we don't want to accidentally update that. Cool. So that's going to do that. And then we're just going to grab this and move it to the index buffer also. Whoop, not what I meant to do. Except here, we know the type. It's going to be a vector of U32s. And so then here it'll be size of U32 or times 4. Oops. Come on, yeah, there we go. Boom. Okay. Nope, that did not take me back where I wanted. Cool. Now, in the flush function, we're going to go through and we're going to say if let sum context equal context. And technically, I should also be checking that we're in a scene. But really, I need the context. I don't actually need the scene data at all here, because it only has the camera transform, and that's getting set when you start the scene, and that's all fine. Okay, so anyway, we're gonna say, come on. We're gonna say context dot positions dot set data, and we're going to give it context. I really should have set that up as a reference. Can I do that as a reference? Will that break anything? It does not seem to, which is good. Same here. Back down here. Yeah, set that up as a reference. So we're gonna say context dot position data. Boom. This dude. Oh man. And then context dot vertex count. Boom. And then texture coordinate or rotations, texture coordinates, texture IDs, colors. Rotations, text coords, CW text IDs and colors, and then same thing here. Rotation data, text coord data, text ID data, and color data. And those are all getting the vertex count. And then we're going to do context dot, did I say that? EBO? Yeah, EBO dot set data and context dot indices. Context dot index count. Yeah, cool. What else? Yeah, so we set all of our buffer data and we draw. I think that's it. So when we end scene, we're going to flush and execute. Ooh, can I do it like that? I can, because I'm inside the renderer. Great. Because the renderer 2D still has its context. Great. Alright, so now we get into the fun part, which is... Oh, excuse me. Now we're getting into the fun part, which is setting up this data, but holy shit. Okay, so we're already at 45 minutes. I think I'm gonna go ahead and wrap this video up. So for next time, all we should need to do is implement the draw quad function. And what that is going to entail is going to be doing the math for the transforms. We're going to set 6 vertices for indices in the thing. And then also all these uniforms, the texture, the color. I'm not sure about the model matrix here, right? So the reason that we can't use this as a uniform is that we essentially, the uniform is the entire shader for the entire draw call, and we can't update it for the individual quads within the draw call. And that's why we're going to create this transformation matrix, but then we have to apply it to our positional data before we actually, you know, do the thing. Anyway, so we're going to be setting up the draw quad function in the next video, and then I'm absolutely certain there's going to be plenty of debugging to do. That will also happen in the next video. For now, I'm going to leave it there. So yeah, I hope you guys enjoyed this video. I am very happy to be continuing to make progress on the engine. So cool. I hope you guys enjoyed the video. I'll see you next time. Bye!